Recapping what we got from StatCrunch, the 90% confidence interval was the lower limit and the upper limit, the 0.1027 or 0.103, whichever one you want to use. I typically round to 3 decimals. And then 0.2007 or 0.201. Now the margin of error is calculated by taking the proportion p hat minus the lower end point, and that will give us our margin of error, because p hat plus our margin of error, or actually p hat minus our margin of error will give us our low end point, and p hat plus our margin of error gives us our upper end point. So we can swap the equation around to add the margin of error over or subtract. Now, p hat was 0.152, the sample proportion, minus the lower limit of 0.1027 gives us a margin of error of 0.0493. Now, in StatCrunch, they give you 99%, not 98. So this is a new value, 2.576. The confidence interval for this was 0.082 to 0.221. And then the margin of error, again, we take our p hat of 0.152 minus our lower endpoint and get 0.07. So notice that the margin of error for the 90% is smaller than the margin of error for the 98%. More confidence you have, the larger your margin of error is going to be. Okay, well now we want to know how the sample size affects the margin of error. So we're going to keep our level of confidence constant, but we're going to change the sample size. Changing the sample size is going to change your p hat. So recall that the original margin of error for the problem with 95% was 0.07. Recall that the 98% confidence interval had a margin of error of 0.07. And so that was 22 out of 145 for our p hat at 98%. We're going to keep this at 98%, but we're going to have p hat be something over 100. And here it's going to be p hat over 300. So let's hop over to StatCrunch and get these values. Stat, proportion stats, one sample with summary. Our number of successes is 22. Now we're doing out of 100, so we're decreasing our sample size, but we're sticking with 98%. And we get a different lower and upper limit. Our lower limit is 0.124. Our upper limit is 0.316. Let's do it again with 300, and then we'll transfer these values over to our paper. Again, 22 out of 300, confidence level of 0.98. We've increased our sample size here, and now we have a lower limit of 0.38 and an upper limit of 0.108. Now remember, our p hats have changed. So our p hat is different for these problems. Copying those intervals down and changing our p hat values. This interval was, if you recall, 0.124 to 0.316. The second interval was 0.038 to 0.108. And remember, our p hats changed. So finding the margin of error, we're going to do p hat minus our lower endpoint, which gives us 0.22 minus 0.124. That's a value of 0.096. So 0.096. That margin of error is greater. So our sample size went down and our margin of error went up. Let's see if we can find the same pattern for the next problem. Our p hat of 0.073 minus 0.038 is equal to 0.035. Our sample size went up and our margin of error went down. So let's generalize that. So sample size increases, margin of error decreases. And this is holding everything else constant. As sample size decreases, sample size should be size, decreases, margin of error increases. Okay, and that's it for Module 20.